We are expecting to have 100-fold more base stations in 5G, and this could only be done if we have a very, very lean and very focused and very capable and high capacity backhaul network that we need, like I said, to redesign. So with xHaul, with our new design front haul and backhaul networks, we will allow the applications and the services to move and to follow the user. So to give a very coarse example, if you have a bus full of people playing and the bus is moving, the backend of the Play server that is attending these users will follow physically being moved from base station to base station to provide the least delay possible and the best possible functionality to the users.
And the purpose of the project itself is to be a pre-standardization activity, so to get consensus and make sure that companies are aligned when bringing this into standards eventually in the future, which will be very soon, perhaps even early 2016.
Some of the use cases that we think is not possible now, but it will be possible when this technology is in place, are, for example, ultra high definition TV and streaming on future mobile devices, and also augmented reality and virtual reality and immersive uses that are now becoming possible on new devices, but we don't have the right network data rates and latencies to support this.
The Flex 5G Web project is about providing proof of concepts for the key building blocks of hardware and software platforms, on top of which all the 5G communication world will rely. But we are in a rainy condition, and then our terminal detects that there is a lot of humidity because of the rain, and then it may change its radio access technology depending on the different conditions, on the different propagation conditions that the RAT will encounter when communicating to the base station. Some other features that are unique of our project, for example, are that we will be enabling an overall bandwidth of operation about 1 gigahertz, which is 10 times more than what we are experiencing today.
The Ppp project is about the 5G RAN design, so the radio access network design, which means that we aim to define the complete functionality for the radio side of the future mobile communications system. One key aspect of the radio access network design is in particular to integrate novel interfaces which we expect to be introduced in the 5G timeframe among each other, and also with legacy interfaces such as, for instance, the evolution of LTE Advanced.
Current technology is semi-automated, but there is quite a lot of human intervention. In a network with tens of billions of devices, it's not possible for a human to actually efficiently manage it, so the networks will need to manage themselves. So the Cognet project is looking at how can we do this? How can we create a network that can actually manage itself at this type of size? We also want to look at how to deal with issues such as problems that arise in networks, faults, errors, security issues, and how to recognize these issues and correct them in advance.
5G enables new applications, like, for example, autonomous driving, remote control of robots, and tactile applications. But these applications also introduce new challenges to the network. Networks today are not flexible enough to cope with the requirements of these new 5G applications, like low latency, high reliability. 5G Norma develops a new, adaptable and future-proof mobile network architecture.
So the main objective of the project is to develop a unified control and coordination control framework for heterogeneous radio access networks. So because in 5G networks, the main problem there is that you have different systems to support different services.
So we think we have to find some solutions, maybe not only to focusing on some specific frequency band, but we have to find a flexible solution how to deal with the problem of spectral scarcity in order to meet the requirements for 5G PPP.
There is no possibility of integrating in an easy manner different kinds of vertical industries, which is a key opportunity and a key objective for within the 5G PPP and generally in the 5G industry. So basically, in Coherent, we aim to enable such a, or facilitate such a system by allowing to the design of the network architecture, which is flexible, programmable, and also enabling the key aspects of software-defined approaches to radio access networks.
Sonata project is about software-defined networks and new virtualized function networks in order to offer the telecom operators and the vendor the capacity to do flexible programmability of the networks and how to deploy new services and orchestrate new services in the networks. Sonata is important because it's embracing or it's adopting one of the key technologies that is going to change the 5G networks, is the network function virtualization. The key point is in the end to offer a new way of working together these different players of the value chain in a DevOps extender model, in which from the full circle in which you develop an application and new services, you test it, you do the qualification of a service and you operate it, the full value chain and the different elements is across several actors and different organizations working together.